Okay, so let's get started. So today I want to speak about Android coroutine recipes. This is the first, my first tech talk here in Sydney. This talk will cover coroutines basics and some practical examples where you can use coroutines in Android. There will be a second talk which will cover some advanced stuff like channels and coroutines with Android architecture components like live data and room, etc. So let's get started. First of all, what are coroutines? So think about coroutines as a lightweight threads, but the main feature of Kotlin coroutines are actually a possibility to write asynchronous code in sequential, direct style. So why actually coroutines were introduced? So to answer this question, let's just take a look what asynchronous API we currently have. So we can use a thread where you need to specify a callback. So let's represent it with just gray squares on the right. So we can also use an async task, which is quite similar, where you also need to specify a callback, and code would look something similar to this. If you go with a bit advanced stuff, there are reactive streams, where you need to chain all these operators to avoid callback hell. But anyway, you still need to specify a callback for your on next or on error. So all these three solutions have a common problem, and that's specifying callbacks. What we actually want is to write a nice sequential code in a direct style, which would look something like this. But we'll get back to the actual code later. First, I want to discuss coroutine building blocks. So basically, there are three main things which you need to understand about coroutines. The first one are coroutine builders. So they are actually used to to launch a coroutine. Then there is a coroutine context. So that's basically a dispatcher, and you can think about it as schedulers in RxJava. So that's deciding which thread your coroutine will be running. And there are suspend functions. So basically, that's a suspension point. So that's your marker for suspension points. So whenever you have some long-running operation, you should mark this function as a suspended to indicate to client that, okay, this function is doing some long-running stuff, and it may take a while, so it may basically suspend. So back to our builders to launch coroutines. So there are quite few coroutine builders. I will introduce you three, the most important one. So the first one is with context. So that's So this function actually launch a coroutine and return you a result. And whenever some uncaught exception happens, it will crash your app. So you'll need to put try catch or handle exceptions there. Next, there is a launch function. So that's basically a fire and forget. So that's launch your coroutine, and it doesn't return you any result. Instead, it returns a job object, and you can use this job object to cancel your coroutine. Again, when some uncaught exception uncaught exception happens there, it will crash your app, so you need to try catch. And the third one is async. So it's a bit different. It actually returns a deferred object, which is a non-blocking feature, which will contain your result. And this deferred object extends job object, so you can cancel it as well. And the key difference is that this deferred object also will contain your uncaught exception. So whenever you launch a coroutine with async function and internally the exception happens, it will be just stored in your deferred object. Now a coroutine context. So again, there are quite a few, but I will focus on three main ones. The first one is basically a UI, which means I want to execute this coroutine on UI context and dispatch everything to main thread. There is a common pool, which basically dispatch execution into background thread. And the third one is unconfident. So unconfident is used, so first of all, it launches coroutine on the same thread. So basically dispatch execution into current thread. And in most cases, this unconfident is used for your tests. Now the third important thing about Kotlin coroutine, which is a suspend function. It's a bit tricky one. So basically, we have a suspend keyword in Kotlin. So as an example, here we have a load data function which return data, and this suspend function, the suspend keyword, tell a compiler. So whenever this function will be compiled, our function will be replaced. Our function will be replaced with one with a signature, which has a parameter continuation. So this continuation is basically a callback. So whenever you are programming with the coroutines and you're writing everything in sequential or direct style, whenever it gets compiled, it will be a state machine with the same callbacks. But you actually don't see this, so you actually don't care. Now it's time to do some coding, and let's try to launch, start some coroutines. So to launch a coroutine, first of all, you need a context. So I've declared here two different contexts. One is a UI context, which basically dispatch everything to UI thread, and a background context, which basically dispatch everything into background context. Next, let's take a look on this method. And we will try to transform it to make it use coroutines. So imagine this method in your presenter. So you have some load data function, which call a show loading, which obviously shows some loading. We have some heavy operation here, which must be run in a different thread. And again, we need to switch to UI thread to show the data and to hide the loading. So first, we need to launch a parent coroutine. So we'll use a launch function for that. If you remember, that's fire and forget. And we will specify a UI context. So that means everything inside will be run on UI thread. Now, we have our data provider provide data function, which actually do some heavy operation. We don't want to run this operation on UI thread. So that's why we'll use with context function, which will spawn a child coroutine, and we will specify a background context, so that this child coroutine will be executed on background, and it will immediately return us a result. So the final code will look something like that. So again, we launch a parent coroutine, which will execute this code on UI thread. Then we'll do our heavy operation on background thread. Then we'll again switch to UI thread to execute the rest of operation. So as you can see, there's no callbacks, and everything is nice, direct, sequential style. Now let's move on and see what other stuff we can do and how we can solve other commonly used patterns. Like let's say we want to launch two tasks sequentially. So in this case, mostly the code stays the same instead of this part. So if you want to launch two tasks sequentially, you just need to spawn one coroutine, then spawn another coroutine, and do whatever you want with results. So basically, spawn one coroutine with another coroutine. So the next question, which you probably have, is that, OK, then how would I launch two tasks in parallel? So in this sample, it's pretty much the same, except, again, the middle part. So here we are replacing our with context function with async function. So as you may remember, this function basically launch a coroutine and immediately return a non-blocking future, a deferred object. So this code will be immediately executed, but result may not be there yet. So you need to call await function, which is a suspended function, which will await when the result will be available. And with this pattern, you can actually spawn your coroutines in parallel. Now, the other commonly used pattern is, for example, if I want to launch some task and with some timeout, because, for example, when you do login and server is not responding, you don't want to wait 30 seconds or whatever timeout is hard-coded in your HTTP client. So in this case, we will just wrap our with-context function, which is basically a child coroutine, with another function, which is called with timeout or null. So that's basically we launch another coroutine, which would check if this coroutine executed in 2 seconds or not. So if it takes more than 2 seconds, it will just return null. There are some other convenient functions which you can use, like with timeout, which will just throw an exception in case if timeout occurs. Now, cancellation, another commonly used sync. So again, imagine this code is in your presenter class. So we have our allowed data, which spawn which do some heavy stuff, just launch a coroutine. And imagine you have on next click it function, which will actually launch this coroutine. And this load data function use a launch function which return a result. So sorry, not a result, but a job. And we can use this job to cancel the work. So let's say we have on back click it function, and whenever user click on back click it, we just call job.cancel, which would obviously just cancel this job. So whenever you have some child coroutines inside your parent coroutine, when you cancel parent, every child will be canceled as well. Now let's speak a bit about error handling. So as I mentioned before, if you have uncaught exception when you are launching your coroutines, it will crash your code. So you need to use a try-catch pattern. And you can use it the same way as you're using it in your any other code. So you just wrap a coroutine with a try-catch and handle all your exceptions. There are some other patterns of doing this. So as I specified before, we can replace our launch with async function, which would launch coroutine, and if something happen inside there, so if there will be an exception, it will be stored inside our deferred object, so it will not crash. Sometimes you don't care about exception, so you may want to use this async, but it's not encouraged to use it. I'm not encouraging you to use this async because in that case you would just mask your error. Anyway, in this case, when you use a deferred object, you can still attach a listener, like invoke on completion for your deferred object, and you can check if it's completed with exception or not. But again, that will bring you back to your callback style programming, so I don't encourage you to do that. The other way of doing this is, again, use a launch function to spawn your coroutine, and then attach exception handler there. So whenever any exception happens inside your code, it will just be redirected to your exception handler. Exception handler, again, is an callback. So again, that's not the best way of handling exception. Now, the other way of masking exception, I would say, is to write your own extension function. So I just wrote an extension function, called it await safe. So that's extension function for deferred object. And I just use a try catch and wrap the await call. And whenever exception occur, I just return a null object. So the usage would look like that. So you, instead of calling an await, you will call await safe. And in case if it returns null, it's basically no data is available. If you do care about exception, again, you can write an extension function which returns some more advanced stuff, like let's say a data object which has a success or failure, or you can make a CLED class which has a success or failure. In that case, you'll just need to handle a success or failure. Next is testing. So how actually test all this asynchronous code which we wrote with coroutines. So imagine you have some presenter class and you're using coroutines there. So basically you need to inject your context. So in a constructor, you just declare a UI context and background context with the default parameter values. And if you want to test this code, we can just use an unconfined coroutine context. So when you specify it, all the work will be done on the current thread, so synchronously in your test. So that way you can test all your coroutines, all your code which use coroutines. Now, some other stuff which may be useful for you. So sometimes you write all your code in your sequential style, you're using coroutines, you're happy with that, but you still use third-party libraries which expose listeners. In that case, coroutines have actually functions and ways to bridge all these callbacks to suspend functions. So you can wrap your API with suspend functions and then use it inside your code, everywhere inside your code in a sequential way. So let's say we have some load data function and we are actually using here, I'm actually using here Firebase. That's a database API or something like that. So basically we have a get function and add on complete listener function which attach a callback. Oops. And we just check if it's successful or failure. So now we'll try to bridge this to our coroutines. So first we need to mark this function as suspended, and then we need to use a suspend coroutine function, which will provide us a continuation. So this continuation then we will use to actually provide a result. So we have a resume function to provide a result, successful result, and we have resume with exception, basically to provide error. So the whole code will look like this. So in this way, you can use your load data. So it's a suspend function. You use your load data in your code and use it in a sequential style. Another thing is that sometimes you have an API which exposes reactive streams like RxJava. So guys from JetBrains wrote a lot of modules which can bridge your Rx or other reactive stuff to coroutines. So in that case, I have a single from Callable, and I've added a module called Kotlin Coroutines Rx2, and it provides us some extension functions. In this case, I use await function. So it will just suspend, and then I can immediately get the result here. So basically, they have a lot of modules here. So for Rx1, Rx2, Reactor, some JDK8 and Neo stuff. So whenever you want to bridge something to your code, to bridge from, let's say, reactive stuff to coroutines, you can easily do that by importing one of these modules. Even for retrofit, we already have adapter. I believe it was written by Jake Wharton. It's still experimental, but whenever you add this adapter, you can declare your API and instead make it return deferred object. So the same way as you use a reactive adapter where you need to declare all your observables, you can declare a deferred object. And Yeah, so the resources, where to go when you want to learn coroutines. So that's basically official documentation. This documentation has different articles which cover core documentation, UI stuff, a guide to reactive streams, and a guide to feature-based libraries. Now, another stuff is that Google has an official repository with samples, which is called Google Samples Android Architecture. So that's basically a to-do app. And there are a lot of samples with, which demonstrate the usage of this application, but with different architectures. So they have the same app with architecture MVP, MVI, MVVM, with the Java, Kotlin, which use live data, etc., etc. So recently I forked that repository and provided, I just took MVP Kotlin sample and replaced it all asynchronous code with Kotlin coroutines. So I have fork of that, and it is also available in official repository because it was merged there. So whenever you open the official repository, there is in the README file, there's external samples. When you go there, there should be a link to my sample. So this sample was reviewed by Googlers, and it was polished, so everything should be okay there. And yeah, that's a screenshot from my commit. So as you can see, code look much nicer there. It's in nice direct style, and we don't have any callbacks there, and even amount of code decreased dramatically. You can also check my article about migrating this to-do MVP Kotlin to Coroutines. There are some interesting notes there. One more article is about Kotlin coroutine recipes, which I wrote before this talk. So it basically has all these recipes which I talked about today, and it has a repository link where you can also check all the samples. Now, if you still don't believe me that coroutines are a big thing and you're still using XJava, you should listen to this guy, Jake Wharton, who recently specified that he started off XJava, he wants to use coroutines, what he's already doing, I believe. And yeah, the last thing which I want to share is Android coroutine survey. So before this talk, I've asked all participants of previous Tech Talk to participate in a survey where I actually asked a few questions, and I didn't get much a response, like maybe 30 or something about it. And actually, the results are quite similar. So around 40% of people answered that they want to use coroutines. 20% already use it in sample projects. Another 20% use it in production already. Another 20% didn't know what coroutines are exactly. And 24% of people answered that they don't want or don't have any plans to use coroutines. So I hope after this talk, this number will decrease. And that's probably all. Thank you for coming to my talk. And this presentation will be available at speakerdeck.com, where I usually post all my presentations.